This is the video for lesson 6.4. Our learning target in this lesson is I can use the triangle midsegment theorem to find distances. So first we need to remember what midsegments are. The midsegment of a triangle, it's a segment that connects the midpoints of two sides of a triangle. So for example, line segment MP here is a midsegment of triangle ABC because it connects the midpoint M, which is a midpoint of line segment AB, to the midpoint on this side, which is P, and this P is a midpoint of BC. So every triangle, you'll notice, has three midsegments. Another important thing to remember is that the midsegments, so for example, this light blue midsegment, is parallel to this side of the triangle. That will be true always. The midsegment will be parallel to one side of the triangle. So our triangle midsegment theorem, in our exploration that we did in the previous lesson, we learned that the segment connecting the midpoints, so the midsegment, is half as long as the side that it's parallel to. So for example, in my picture, the midsegment DE, it is half the length of side AC that it is parallel to. If you were going to write this as an equation, you would say the length of DE is equal to 1/2 times the length of AC. So we're going to go ahead and apply this triangle midsegment theorem to some problems. I need you to turn in your journals to page 182. We're going to start with exercises 1 through 3 on page 182. It says in exercises 1 through 3, DE is a midsegment of triangle ABC. Find the value of X. Okay. So in triangle number 1, DE is the midsegment. And what that means is the side it's parallel to, which is BC, it is half the length of BC. So X is going to be 1/2 times the length of BC, which is 28. Remember, multiplying by 1/2 is the same thing as dividing by 2. So we get that X is equal to 14. In number 2, this time we know the length of DE, and we're trying to find the length of the side it's parallel to, side BC. Well, if DE is half the length of BC, if I take the length of DE, which is 15, and I double it, or I times it by 2, that will give me the length of BC. So the length of BC, X is equal to 30, because 15 is half of 30. In number 3, they tell us that DE is the midsegment. What that means is point E here is the midpoint of side AC, meaning it's in the middle. So if E is the midpoint of side AC, it means this segment, AE, is congruent to this segment, EC. So X, if AE is 9, is also 9. We're now going to go ahead and go to number 5. Number 5, they ask, what is the perimeter of triangle DEF? First, we need to remember what perimeter is. Perimeter, remember, is the distance around a figure. In other words, it's the length of all the sides added together. So we want to find the perimeter of this yellow triangle here. To do that, we need to find the length of all three sides. Let's find the length of DE first. DE is a midsegment of the triangle, so I'm going to look at the side it's parallel to, BC. BC is 45 units long. DE is going to be half that length. So I can go ahead and multiply 45 by 1/2 or divide 45 by 2. And I get that the length of DE is 22.5. I'm going to put that in my picture. Let's find the length of FE now. The side that FE is parallel to is AB. That has a length of 13. So I want to take half of 13. When I do that, I get 6.5. So the length of FE is 6.5. To find the length of DF, I need to find the side of the triangle it's parallel to, which is AC. AC has a length of 38, so I need to take half of 38 to find the length of DF. When I do that, I get 19. So DF has a length of 19. So remember, to find the perimeter, I need to go ahead and add up these three sides of this small triangle here. So the perimeter of triangle DEF is equal to 22.5 plus 6.5 plus 19, which is equal to 48. Another way you could have done this problem, and some of you might have thought to try this, instead of finding all these lengths individually and then adding them up, you might have said, okay, well, I'm going to find the perimeter of the larger triangle, and once I find that perimeter, I'm going to divide by 2, because I know that the perimeter of the smaller triangle will be half the perimeter of the larger. So if you would have found the perimeter of triangle ABC, you would have added up all three sides. So 13 plus 38 plus 45. And you would have got 96. And then to find the perimeter of triangle DEF, you could have taken 96 and divided it by 2 or timesed it by 1/2. And you still get 48. So there were a couple of different ways to solve this problem. The method that, I showed in purple here, sorry, you couldn't see that, is probably quicker than finding all the individual lengths. But whatever method makes most sense to you, go ahead and do that. Finally, the last one we're going to do together, number 6. I changed number 6 a little bit to model more of a problem that you need to know how to do. So what I need you to do to fix this problem is change side BC from 52 to 2x plus 52. Then change the length of DE. Add this in. There's no length there. We're going to make this length 3x minus 12. And now we're going to go ahead and solve this problem. It says in the diagram, segment DE is a midsegment of triangle ABC, and segment FG is a midsegment of triangle ADE. So we've got a few triangles here, and we have some different midsegments to look at. Our final goal is to find the length of FG. We're trying to find this length here. Now, before we do that, we have to find the value of x. I've got some x's in my lengths. So I'm going to have to set up an equation. So what we need to do is we need to think about that midsegment theorem and think about how the midsegment relates to the side of the triangle it's parallel to. So I'm going to go ahead and look at these two sides that I have some information about. DE is the midsegment of triangle ABC, meaning it is equal to half the length of BC. I'm going to write that out. DE, my midsegment, the length of DE is equal to half, 1/2 times the length of BC. This is how I'm going to set up my equation. The length of DE, they tell us, is 3x minus 12. So 3x minus 12 is equal to 1/2 times the length of BC. Now, when you times the length of BC, you need to put BC in parentheses. The length of BC is 2x plus 52. I'm going to go ahead and solve this equation to get x. One way you can solve this is to use the distributive property, times both terms inside the parentheses by 1/2. 1/2 times 2x is 1x. 1/2 times 52 is 26. I see x's on both sides of my equations. I want to move them to one side. I'm going to subtract 1x from both sides. I'm going to add 12 to both sides. And then finally divide both sides by 2. And I get x is equal to 19. Now be careful, they didn't ask me to find x. They asked me to find this length here. So first, what will be helpful is I want to take my x value now, and I'm going to plug it in to actually get lengths for DE and BC. When I substitute 19 in for x, I get 45. So this length here is 45. This length here would be 90, right? Because 45 is half of 90. And I need to figure out what the length of FG is. Remember, segment FG is a midsegment of this triangle. That means the length of FG is half the length of DE. So FG has a length that is half of 45. So if I take 45 and I times it by 1/2 or divide it by 2, I get that FG has a length of 22.5.